talking about angles of elevation and depression. And again, like I said, elevate means to rise above, depress means to fall below. An angle of depression is the angle formed by the horizontal line and the line of sight to an object below the horizontal line. So if you have a guy that's standing up here on the balcony of a restaurant and he spots somebody down here on the observation desk, okay? If he were to look straight across, this would be his horizontal line of sight. Okay, that would be his horizontal line of sight. If he were to look down at this person on the observation desk, this is his new line of sight. Okay, so you got a horizontal line of sight. He looks down, okay, and that's a new line of sight. The angle that's made as he looks down, he presses below that horizontal, is called an angle of depression. Okay, it falls below the horizontal line. It's called an angle of depression. Okay. All right. Now, let's say that the guy on the observation deck spots the guy at the restaurant. Okay. Well, he has a horizontal. Gosh, I can't spell. He has a horizontal line of sight. That goes straight across. But when he looks up at the guy on the observation deck, that is his new line of sight. So here's his horizontal line of sight, and he looks up. The angle that is created by that horizontal line and the new line of sight is called an angle of elevation. So I'm going to abbreviate that AOE. Okay? So your angle of depression depresses below the horizontal. The angle of elevation rises up above the horizontal. Okay? All right. So then we can continue on. So angle 1 is an angle of depression. Angle 2 is an angle of elevation. Now, the guy on the observation deck spots somebody at the base of the tower. Okay? So here is his horizontal line of sight. He looks down at the guy at the bottom of the tower. What would angle 3 be? An angle of depression, because it falls down, it drops down below that horizontal line. So that's an angle of depression. Okay. Angle 4, okay, here's the guy that's down at the bottom of the tower. Here is his horizontal line of sight. He looks up at the guy in the observation deck. What is angle 4 going to be? Angle of elevation. Okay, so again, your angle of depression drops below the horizontal line. It's that angle that's formed by the horizontal line and your new line of sight. The angle of elevation rises above the horizontal line and looks at something above. It's the angle formed that rises above. Okay? All right, now these two angles have a relationship. One of them drops below a horizontal line, one of them rises up above a horizontal line. So I've drawn a little scale here, and what's true about horizontal lines? They're parallel, right? Okay? The line of sight acts as a transversal. Okay? So you've got horizontal lines, you have your line of sight, it acts as a transversal. What relationship is your angle of depression and your angle of elevation going to have? They're congruent, because what kind of angles are they? Alternate interior angles, right? Okay? So alternate interior angles are equal. So your angle of depression is actually also an angle of elevation. You can transfer that information from here to here. And really what happens is if you draw two vertical lines, you can create a right angles, okay, which creates a rectangle, okay? And remember, in a rectangle, your opposite sides are equal. So if I'm given, an information about something here, let's say it's 8, if I needed to, I could bring it over here because this is going to be 8 if you create a little rectangle. And you'll see how this works here in just a minute, okay? All right, so let's do some examples. Nadine sees the tour bus from the top of a tower. To the nearest foot, how far is the bus from the base of the tower? Okay, so here is Nadine, okay? This right here is a tower, okay? And here is my bus, all right? It says she sees a tour bus from the top of the tower. To the nearest foot, how far is the bus from the base of the tower? What is this 23 degrees? It's an angle of depression because it's depressing below the horizontal line, okay? So that's your angle of depression. The tower is here. We're wanting to know how far the bus is from the bottom of the tower, okay? So my unknown is going to be right here. Now, I have myself a little right triangle here, but what do I need to do with this 23? Put it down here, right? Okay? I can move it down here. Now, I heard somebody say subtract it from 90. Could I find this angle here? Yes, that angle is always going to be complementary to your angle of depression, okay? So we could make this, what is that, 67? You could do that if you wanted to, okay? All right, so I moved my angle of depression now to be my angle of elevation, but remember, they're the same, right? Okay, so with that said, I now have a right triangle. What am I going to use to figure out that distance from the bus to the bottom of the tower? Tangent, right? So I'm going to take tangent of what? 23 equals 180 over x. Now, I did say that you could make this, what, 67? You could use that angle and do the tangent of 67 equals x over 180. You could use either one of those. It doesn't matter. Okay? All right. But if I was going to use this one, I would have to get the variable out of the denominator, multiply both sides by x, and I have x tangent of 23 equals 180, and then what do I do to solve it? Divide by the tangent of 23. Okay? So in my calculator, I'm going to do 180 divided by the tangent of 23, and I end up with 424 is to the nearest foot, so that would be 424 feet. So the bus is 424 feet from the base of the tower. All right, let's look at the next one. Any questions on that one? Okay, let's look at the next one. All right, the crossbar of a goalpost is 10 feet high. The crossbar of a goalpost is 10 feet high. If a field goal attempt is made from 25 yards from the base of the goalpost that clears the goal by 1 foot, what is the smallest angle of elevation at which the ball could have been kicked to the nearest degree? Okay, so we have a goalpost, right? And it says that it is 10 feet high. It says if a field goal attempt is made 25 yards from the base of the goalpost. So you have your kicker, okay? He is 25 yards from the base of the goalpost. And he wants to clear by 1 foot. So he's going to kick the ball so it clears by 1 foot. What is the smallest angle of elevation at which the ball could have been kicked to the nearest degree? Okay? So what am I looking for here? An angle of elevation, which is going to be right here. You want to know at what angle they're going to kick that ball, all right? Now, how high is it going to have to go up? 11 feet, right? And it says that he's 25 yards from the base of the goalpost, but that's yards and this is feet. So what do I need to do? Change this, right? And how many feet are in a yard? 3, so that'd be what? 75 feet. Okay, so now what am I going to use to figure out this angle of elevation? Tangent. So I'm going to do the tangent of x equals opposite, which is 11, over adjacent, which is 75. Now, am I going to use regular tangent or inverse tangent? Inverse. So second tangent, 11 divided by 75, and you end up with 8.3 degrees. Now it says round to the nearest degree, and if you were to follow your rounding rules, that would be 8 degrees, right? But if you made your angle just a little bit smaller, would it necessarily clear it by a foot? No, so I'd probably want to go up to 9 degrees. All right. Any questions on that? Okay. Okay. For a reverse bungee ride, Reagan stands halfway between two vertical posts. Two bungee cords extend from the top of the post to Reagan's waist at a height of 1 meter above the ground. How tall are the vertical posts? Okay, so these are identical, right? And I'm trying to figure out how tall they are, okay? Here is Reagan, okay? And these bungees right here are tied to her waist, and her waist is 1 meter above the ground. Now, the distance between the two poles is 8 meters, right? So if we looked at the distance from Reagan to one of the poles, what would that length be? 4. Okay? All right. And so I need to figure out how tall this pole is. But once I figure it out, I can use this triangle, and I can find this distance. But if I want to find out truly how tall they are, what am I going to have to do at the end? Because this is tied to her waist, which is 1 meter above the ground. Add a meter, right? Okay. So this is what my triangle looks like. This is x. My angle of elevation is 70, and this is 4. Okay. So what am I going to use to find out that height? Tangent. So I'm going to do the tangent of 70 equals x over 4. Okay. I want to solve for x. So I'm going to multiply both sides by 4. Okay, so in my calculator, am I going to use regular tangent or inverse tangent? Regular. So I'm going to do 4 tangent of 70, and it ends up being 11 meters. 11 meters. Okay, but how tall are they going to be? Well, it's 1 meter, so it's 12 meters. All right, here's another one. Leah is meeting friends at the flagpole in the park. She sights the top of the flagpole at an angle of 38 degrees. She knows that the flagpole is 25 feet tall. If Leah is 5.5 feet tall, about how far is she from the flagpole to the nearest foot? Okay, so Leah is 5.5 feet, right? The flagpole is 25 feet. We want to know how far she is from the flagpole, okay? Now it says her angle of elevation to the top of the flagpole is 38. This right here rises up above the horizontal is 38, okay? I want to know how far she is from the flagpole. Now, when I go to do this problem, am I going to use the whole height of the flagpole? No, because you're going from how tall she is, right? So I would have to take 5.5 away from the height of the flagpole, so the height of the flagpole is actually going to be 19.5. Okay, so what am I going to use to solve it? Tangent. Okay, what's that going to look like? Tangent of 38 equals 19.5 over x. Could I have found this angle and used it? Yeah, I could. Okay. All right, but I didn't, and that's okay. Multiply both sides by x. So I have x times the tangent of 38 equals 19.5. And then what am I going to do? These are multiplied together, so I'm going to divide by the tangent of 38. Okay, so in my calculator, I'm going to do 19.5 divided by the tangent of 38. And you should get 25 feet. Is that what you guys got? So she is 25 feet from the flagpole. All right. Last one. Okay. A plane flying at an altitude of 12,000 feet begins descending when the end of the runway is 80,000 feet from a point on the ground directly below the plane. Find the measure of the angle of depression to the nearest degree. Okay, so we have our little airplane, okay, and it says it's flying at an altitude of 12,000 feet. What's altitude? How high up he is, right? Okay, so he's 12,000 feet in the air, okay? All right, it says when the end, he begins descending when the end of the runway is 80,000 feet from a point on the ground directly below the plane. So here's the runway, Okay, and he begins descending, okay, to the runway when the end of the runway is 80,000 feet from a point on the ground directly below the plane. Where's that 80,000? It's where? The runway? Here? Or how about here? Okay, it says it's when the end of the runway is 80,000 feet from a point directly below the plane. So here's the end of the runway. Here's a point directly below the plane. So it would be this distance right here. Yeah, because that's where he would touch down. Yeah. Okay, and then go on. Okay. All right. Now, it wouldn't be this. This would be his flying distance. Okay? That would be 80,000 for flying distance. This is ground distance. Okay? All right. Now, it says find the measure of the angle of depression to the nearest degree. Where's that angle of depression going to be? The one by the runway at the 80,000 feet? Okay? That's really an angle of elevation, but what did we say? They're the same, okay? Here's the horizontal line, right? This right here is my angle of depression, okay? So if I move it down here, it's also my angle of elevation. A lot of people, everybody listen to this, try to make this it, and that is not, and I'll tell you why in a minute. You'll understand, okay? It has to drop below the horizontal, okay? So the horizontal is one side, and then the line of sight is the other. And you can always transfer it down here, okay? All right, so what am I going to do to solve this? Okay, I'm going to use tangent. So the tangent of x equals, okay, 12,000 over 80,000. All right, so am I going to use inverse tangent or regular tangent? Inverse. Okay, so second tangent, can I just do 12 divided by 80? Yeah, unless you just love all those zeros. Okay, so we end up with, it says round to the nearest degree is 8.5, so it would be about 9 degrees, right? About 9 degrees. Okay, so this right here is 9 degrees. That's the angle of depression. Now, if you had put your x here, you would have gotten 81 degrees for your angle of depression. Now, let's think about that. You're flying in an airplane, right? And you're going to make an 81 degree depression to land. Is that good? You would be terrified, right? That's almost straight down, okay? So sometimes when you get an answer, you have to think about it. Does this make sense? Okay? All right? So, be careful, all right? Because there's probably a problem like this on the test, and every year I get people going at a, an 89 degree angle of depression. I'm not going to be wanting to ride on that airplane. So. Anyway, all right. Any questions? Okay, now.
Sorry, are you obsessed with driving?